Hi, this project is related to simulation study of drain current in metal semiconductor field effect transistors as a function. In short, we called it MESFETs, okay, as a function of temperature and gate source voltage. Basically, in this project, we just analyze the study of drain current in metal semiconductor field effect transistors as a function of temperature and gate source voltage. Basically, the results of simulation reveals the intricate relationship between these parameters and the drain current characteristics of MESFETs. Okay, so the thing is that the drain current decreases with the increasing of temperature, which highlights the significance of thermal management in MESFETs-based electronic circuits. The physics of semiconductor devices basically is the behavior based on the behavior of MESFETs, okay, metal of semiconductor field effect transistor. So we need to analyze the current of drain current according to the temperature, gate source voltage with the temperature as well. Okay. So here is I just define the complete abstract with the introduction, like how the current and the temperature varies according to inversely proportional each other, and then how gate source voltage impact their reliability, efficiency on metal semiconductor metal uh, semiconductor field effect transistor basically. Okay, so I have defined the complete uh, gate levels voltage. I have defined the complete complex process with the voltage level, with the current level of gate transistors, with the semiconductor devices. So these are the introduction image, like how the drain current in MESFETs as a function of temperature and gate source voltage added here. Okay, the importance, what is the importance? The importance is that we need to get the high frequency and high power electronic application due to their excellent performance characteristic. Basically, the metal semiconductor field effect transistors are used for electronic purposes, okay, high speed electronics communication purposes. So that's why we need to get the high gain, low noise and high power handling capabilities. So that's why we use it in our cases. So that's why we define this temperature and gate source voltage according to the MESFET's behavior. So I have defined the objective of the study, because the objective is that we define the function of temperature and gate source voltage, aiming to providing valuable insights into the behavior of these devices. So in short, we are checking the efficient and reliable MESFETs based electronic systems. The problem statements basically, we are facing a problem like that, how the temperature is affected on the gate source voltage, how the leading of drain current impact the reliability and efficiency of electronic circuits. So the thing is that therefore we need to investigate the impact of temperature and gate source voltage on drain current in MESFETs to optimize their performance and design reliable electronic circuits. The research questions basically, research purposes question ask how, what is the drain current, how the drain effect current effect on temperature, how temperature effect on drain current, how the gate source voltage on the drain current impact on drain current, how the behavior of MESFETs under various temperature and gate source voltage conditions. The objectives is that we need to identify and investigate the relationship between temperature, gate source voltage and the drain current of MESFETs. Mathematical approaches here, we use these kind of drain current uh, equations and the temperature dependence values as well. Okay, so that gate source voltage dependence is here and the MATLAB simulations is there. Okay, these are the values we used in our cases to analyze the drain source and the MESFETs behavior in MATLAB simulation. Okay. Yes, this one, like how the VGS mean gate source voltage. Okay, for example, gate source voltage is 0. The current and the temperature behavior is that we defines that the temperature increases in Kelvin, then the current also decreases. When the temperature increases, current decreases accordingly. Okay. So next one is basically when the gate source voltage is in negative, then the behavior of drain current and the temperature is slightly changes, like see in the previous current, the with the increase of temperature current slowly decreases, but with the temperature current efficiently decreases. Okay, yeah, temperature again -2, then again the current decreases with higher speed. Okay, I have just added all the references is here, and yes, this one. Okay, these are the variations of temperature with drain source, like uh, how the current is decreases accordingly. Okay, the with the gate source voltage is in negative volt, and this is a drain current versus gate source voltage at different temperatures levels. Okay, see the voltage source is in negative and the drain current will be negative and the at different temperature levels. So this is our conclusion and future work also added in it. And let me just show you, these are the MATLAB files, 3 MATLAB files. Let me just, yes, this one. For example, let me just run this first drain current in MESFETs. Yes, this one is basically the behavior of different gate source voltage according to the changes of gate source voltage. Then here is the comparison behavior of drain current, gate source temperature values. Okay, this is a comparison with the drain current versus gate source voltage at different temperature levels, and how the variation of temperature with drain current. Okay, so variation of temperature with drain current according to the gate source voltage. So this is a complete project. If you need to ask anything, you just call me. Thank you.